So in the first video I had a general overview of how the application works and this one the plan is to explain how the authentication system works, so the login and the register screen. So you might notice that the login and register screen look very similar, and it's because I'm reusing the same basic template for both of them. So I'm using Bootstrap to, for example, for the styles and for the some different components, like for example the button and this toggle navigation. So let's have a look at the source code for the register and login screen. So if we go to character way, we can go to screens on GitHub, and so this is a public repository, so anyone can have a look at it, and it is linked to in my write-up. So go to register, and so this is the code for it. So we have an auth form, which is why it looks so different, so similar. This auth form basically takes in the values of it, so whatever you type in will be the values, and how to handle any change in the values, so when you click a new key, and handle blur. I'm not quite sure what handle blur does, but it does something. We have also handle submit, so once we finish typing it, we click the button, the submit button, and also we have a handle submit. Sorry, it is submitting, which we use to disable the button while we are submitting. Okay, so and if we go to the login screen, you actually see that it's basically the same thing. Basically same thing down here. So we're reusing this component. So we'll have a quick look at what auth form is, but let's have a look at what the differences are. So for the login screen, you'll see this, but for the so this would have actually, I think I should explain the register bit first. So let's go back to register. So for the register screen, so it's actually I just had to check if we're the same one or not, but because it's so similar. But for the register screen, we're using the register. This is a register mutation. We get it from use register mutation, which we get from GraphQL code generator, which is a library that I'm using to help fetch from the API. Okay, and this gives us a tool that gives us a simple way of basically sending the information we want to send to the API. So basically, when we want to log in, we want to send the email and the password to the API, and we can literally do it with this one line of code because of this register mutation. And because I'm using GraphQL code generator, I also get type definitions, so I can tell if this exists or not. Actually, that's not what it does, but type definition would just let me click dot for example, and it would autofill, and that's pretty nice. And so in this line over here, we're checking if the register. So what the register returns, it returns true if the registration was successful. So we check if the registration was successful, and if it isn't, we create an alert, and if it is, we navigate to the login screen. So let's see this in action. So we can create a new account, call it A3, and an appropriate password. So we want the password to be. So let's just check what happens when we write a 7-character password. So we'll say the password must be 8 characters long. How about if we instead not use a valid email? Well, it says we need an @ symbol for it to be an email. And this is this comes in with HTML, which is pre-built. If you just tell it it's an email in the type of the divs, so not divs, type of HTML text, and over here for password it will just put little dots in place of the characters. So this does not exist in the database at the moment, and neither does this email doesn't exist in the database at the moment. So we can create this user. So click submit, and you see we got redirected to the login. And so that's just this bit. And if we go to the screens, we can go to login screen. The login screen is very similar, except we have login over here, and we send in an email and a password, and we get a response. The login response is actually going to be an access token. And this token we can then use to authenticate the user, and they can do various user-specific activities. I should quickly explain what the auth store is. So if we click on here, we can actually go to the auth store, and notice how we navigate. Just say that we navigate back to home page once we've logged in. So let's have a quick look at auth store. So auth store is a class. Basically, what it is it's kind of a class that we only ever use once, and it's used to store the access token. So the reason we can't just store the access token as a string, for example, well, we are storing it as a string, but we can't just store it as a string in a file, is because we wouldn't be able to modify it. One reason is we wouldn't be able to modify it, but we would be able to read it, but we wouldn't be able to modify it. And if we did modify it, there's no guarantee that everything would update in our website, because of how React works. It has to know that there's a change, and one way to get around this problem is use the state management library. And I'm using MobX, and with MobX we have this thing called make auto observable, and we can wrap our class in this make observable thing as a function, and it basically just lets us modify it, and it will update if we modify the access token anywhere in the program, it will update it like throughout, so all the changes will be like accessible right away from anywhere in the application, which is very useful. Okay, so we have that. So let's have a quick look at the database. So over here, actually before we do that, we should go over to the API and just go over to the API. So we'll go back to home. So here's the code for the API, and this is also linked in the write-up. So the smart objectives is that you should be able to create users, and creating users is important, because without being able to create users, you wouldn't be able to create recommendation lists. In fact, no, you would be able to create them, but you wouldn't know who created them, and therefore you couldn't update it. And CRUD is also one of the core functionalities of my program, one of the essential features. So we have resolvers, and we're going to go to the user resolver over here. And so we can see, if we go down here, we can see here is a login mutation. So and here's the register mutation. So our register should go first. We have this first line checks if the user exists, and we use the get user by email method. And this is a method that is something that I implement myself, and also create user. And this is from the same class. and so we'll have a look at that in a second. And so we check, we basically just take the email. So when we register, we take the email, we check if the user exists. If it does, we say the user exists and throw an error, so that we can't make another user with the same email. Otherwise, we basically hash the password with a hash of 12. So the 12 isn't the hash, I think it's the length of the hash, and then we get a hashed password. And using the email and the hashed password, we can create a user, and at the end we return true to say it was successful. So we saw the client side that it checks if it's true or not, and basically it will be false if it's if there's an error or something. So let's have a look at this bit over here. So data sources. So these classes, they give you some useful ways of accessing the database. So we have get user by email, get users, and create user. So the way this works is you get Apollo server, which I'm using to create my API. It gives you data sources which you can connect up to your database, and then you can actually inherit from the data source, and then you can create your own methods for your data source, which you can then pass in, and you can, once you've created it, you can pass into the context of your application, and then it can be accessed anywhere in your application, and in the API, and then you can access the database from anywhere in your API. And I'll just show you where exactly this happens, because it's probably best just to see. So over here in index, you have data sources right here, and this is the one we're interested in. We have new users, and basically we have a database connection, which is from over here. We connect to Mongo, and we use a link to Mongo, which is stored as a environment variable, because otherwise anyone will be able to connect to my database, which is not something I want. And we connect to the users collection. Collections in MongoDB is similar to a table, and we now every time we access users in data sources from our API, from the context in our API, then we can query the database essentially. So we have that. We have querying the database using data sources. And okay, so I think the next thing to talk about would be how exactly the authentication works. So we know we can register, and we can create an email. And so this is what the register looks like in the API. So basically, you send an email password in this format, and you send in this mutation, which tells the API what to do with this email password you gave in. So basically, you register with the email password. So as simple as that. And for the login is very similar. You get email password, except login doesn't return true or false. It returns an access token, and this access token the users can then use to do user-specific activities. So let's see, and I think we can have a quick look at how the access token was generated. So if we go over to resolvers and use a resolver down all the way to, and right here. So over here we check if the user with that email exists. So if it doesn't, we say we could not find a user. So we're logging in, we check if the user exists, and if there isn't, we return an error. Then we check if the password's correct. If the user does exist, we check if the password's correct. So we use something called bcrypt.compare. We can't compare it ourselves because we're using a salt, so we have to use bcrypt compare, unless you want to go ahead and try to loop through every single salt. I mean, you could do that, but you might as well just use a library because you got it. And if it's not a valid password, you just throw an error saying bad password. Okay, now what you do, like if it's not a bad password, and you get all the way down here, we return an access token. So the access token is made using the user's ID, which we would need to identify who it is that's sending us an access token, and we also have a secret, which just makes sure that other people can't make fake JWT authentication tokens. And we also have an expires in 15 minutes, so that if people steal the cookies, they only have a very short period of time when they can use it. Sorry, not cookies, the access token. I should mention that the access token is not stored as a cookie or in local storage for security reasons. It's just stored in memory. That way it's safe from cross-site scripting and so on. Not so on, it's just safe from cross-site scripting, and also it can't be accessed by JavaScript, which is basically cross-site scripting. Because it's not like local storage. I think I said that a couple of times, my bad. I just specifically wanted to say there was a reason I did that. Because I tried to store it as a in local storage before, and people refreshed, and it was like, actually, no, that's not. No, I wanted to store it in local storage because so that when people refresh, they don't suddenly get locked out. But it didn't work out very well. So over here we have the database where the users are stored. So in the Orinogecan database, we have reckless and we have users. So the users, oh, it's loading again. We have the user's ID, which is an object ID. We have an email, and the password's hashed, as you can see. And over here we have a token version, which has to do with the fact that we allow people to revoke tokens. For example, we allow people to log out, which is what this token version thing is for. So every time you want to log out, for example, we would increment the token version by 1. However, in the most recent one, I have not been using token versions for revoking authentication, just because it just lasts so short of time, and it's just unnecessary complexity. So we have that. I think that is almost all. Okay, so one last thing I should mention: how we're using JWTs to do authentication, but how does the API know that the user has an authentication token? Well, they actually pass it out from let's see over here. So whenever the user sends a request, the API then goes ahead and passes out the authorization header from all the headers in the request, so the HTTP request. And if there's no authorization, basically it returns an empty object into the context. And there is more stuff in the context of the empty object, but it just we return this. So it's just anything else in the context already will just be added into here. And similarly, if there's any errors when we're trying to access the access token from the authorization, we also just return the empty string. But if there's no errors, then what we can do is we can just go ahead and take the access token, verify it, check if it's like not malformed or not expired. Then if those conditions are met, we can just take out the user ID from the token and then just go ahead and put it into the context. So what does putting it into the context look like? Well, let's look at something that requires user authentication. Authorization. So for example, go to rec list. So over here, creating a rec list needs authentication. So if we go over here, seems like this. Okay, this is something I made myself, which basically just checks if the user's there. It's just an initial check, just check if the user is there, and if it is, then it will just run this. Otherwise, it will just stop and just say you are not authorized to do this, and that's what the API returns. But if you are authorized, you can use the context like this. So we can take out the user ID from the context, which you just got from the request, and we've verified that the token is completely good. So we can just go ahead and do all this. And this is the data sources we were looking at earlier. So we have the user's data source, which lets us take information from users, and rec lists, which lets us take information from rec lists, and we can just use both to create a rec list. We need both. We need the user's email, and also we need to be able to create rec lists. And also create empty rec lists is one of the methods I created with the MongoDB drivers. And also, just quickly, I should just show you how exactly where those classes that I made for the MongoDB drivers are put in. So it's just there. I might have mentioned this already, but you can't remember. So if we go back to counterweight, I think. So now we know how the API gets at the HTTP, the authorization from the HTTP headers. How does the client side send it over in the first place? Well, Counterweight uses Apollo client. So Apollo client is basically a client library for GraphQL APIs, and so that gives us a nice way of sending stuff via headers every single time we send out a request. Yes, so that's what it is. So remember how I talked about the authentication store? So basically every time we update the access token, this part will be called again, and token would be updated. And over here we have, so auth link is actually part of a series of things we send out, that we connect up and send out to the so auth link is something, it adds the authorization to the headers that we send to the API. So basically we just take out the access token, which we got when we logged in, and we just put it into authorization, just like that. So we check if the token exists. If it does, we send bearer token. This is convention, putting bearer in front of the token, and otherwise we just send an empty string. And every single time we send a request, we'll send this out. If there's no access token, it will just send an empty string, because this will be basically, it would evaluate to false in JavaScript. And so that's essentially it for the authorization. And yes, so get authentication token from local storage. In fact, this is something I changed. It used to be from local storage because that's what the documentation recommended, but I changed that. Now it's from MongoDB and stored memory and returns headers. So HTTP link, you can read them, and HTTP links over here. So that's about it. So thanks for watching until now, if you did.